Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In today's session, I will go over the exponential graphing exponential functions for Algebra 1. I plan to do another one that is for Algebra 2, meaning with the graph transformation. Part of it can be applied also. Maybe I will touch on some points here that can help you as Algebra 1 students. So when we say exponential graphing, you learn about uh, linear equations, right? You can graph a straight line, if you know the slope and the y-intercept, or you know 2 points on it, or the x and y-intercept, as I mentioned to you once. So exponential graphing is similar. We also want to find two things, okay, to be able to draw any exponential function. So the general form of it is y equals ab to the x. So a here, in this case, it's the y-intercept. So similar to the b for the linear equation. And the b here is a parameter that basically it's the rate of growth or decay of the function itself, and we'll see what that means in a second. But if I look at this, I see that for the linear function, when I had x and y, every time I increase x by a particular amount or decrease it, the y would increase or decrease by also the same amount. Meaning, the rate of change of y with respect to x was constant. That's what we call the slope, or m. So m is telling you by how many units y would increase or decrease if I change x by 1 unit. If I increase x from 1 to 2, how much would y increase or decrease? So if it increases, the m is positive. If it decreases, the m is negative. Here, instead of saying by how much it increases, no, it's multiplied by a constant. So every time you change x, y would increase, but by the same product instead of by the same value. You see what I'm saying? Meaning, if I had, say, a linear equation, I say x and y. So, for example, if x is 1, y is 2, and x becomes 3, y is whatever, let's say 10. When x is 4, this is 14. So you see that when x increased by 2, y increased by 8, meaning for every unit increase, y would increase by 4, right? So the slope is 4. You see, when it increased by 1, that increased by 4. If this increased by 10, that would increase by 40. So this ratio is constant. But for the exponential is not the same. We will take some examples and see. But as we said, a here is the y-intercept, similar to the b when I said y equals mx plus b. But the b here, in what we are going to do, we are going to say if it's between 0 and 1, that is a decay, meaning the function will keep decreasing by the same ratio, not by the same amount. So here it may drop for every increase of x, for example, b would increase or decrease fourfold, not by a specific value, but by a specific product. And if b is greater than 1, we say that's a growth. When b equals 1, it's no longer exponential function. This is a straight line, a horizontal straight line, because 1, if b is 1, 1 to the x, where x is any number, is 1. So you get y equals a, which is a horizontal line passing through the y-intercept a. Okay, so it's no longer exponential. We will see also, what if a is negative? When a is negative, you will see that our graph will reflect about the x-axis. We may see an example like that. But let's start with some examples here. We'll see how we plot them. So the first example says y equals 1/3 times 2 to the x. Usually we'll ask you to do a table of x and y values and then just plot that. That's the easiest way to plot any graph, right? It's working. Yeah. Okay. So we are going to say here is my x, here is my y. And I take some values. I know that the y-intercept is 1/3. How do I know that? Because we say this is a. Or I set x equals 0. If x is 0, any number raised to the power of 0 other than 0 is 1. So you get y equals 1/3. That's why we say it's the y-intercept. Okay? Now, if y is 1, 2 to the 1 is 2, times 1/3, you get 2/3. Notice, somebody will say, oh, it increased by 1/3, so why it's not linear? I said, no, it doubled. How do I know it's double? Because of the 2. If that was a 3, it will triple. If it's a 10, it would be tenfold. If it's 1/2, it will become half, and then a quarter, and then an eighth, and so on and so forth. If I put a 2, 2 squared is 4 times 1/3 is 4/3. Do you see that here I multiplied by 2, I multiplied by 2, but here I added 1. I added 1. If I add both to x and y, it's linear. But if I add or subtract to x and multiply or divide for y, that's exponential. So now if I want to plot that, I can get a graphing paper or any paper and say, okay, here is the x-axis, for example. I know for this equation, the x-axis or y equals 0 is an asymptote. What's the meaning of asymptote? Means that my graph will, every time I increase x, it will approach that line, but will never cross it. You will see when we can cross the x-axis when we talk about, or maybe I will touch on that here. So here is x is 0, here is x is 1, or let's make one, let's make 1 here. Let's write it in a darker with a pen. 2, 3. And for the y, again, this is 1, this is 2, this is 3. Now, at 0, we have 1/3. So 0, I have this point. At 1, I have 2/3. At 2, I have 4/3. At 3, I will have 8/3, and so on and so forth. And when I join these points, I get something that looks like that. And on the other side, it becomes asymptote to the x-axis. And this is y equals 1/3 times 2 to the x. Okay, so that's since the b was 2, I don't care about the y-intercept. Since this is greater than 1, that's a growth. If it were less than 1, it would be a decay. Okay, now let's move to the next function. Y equals negative. What's the negative? Yeah, you can write whatever you want. -4, that's the y-intercept. So the graph would intersect the y-axis at -4, below the x-axis. Remember, we said the x-axis is in asymptote. So my graph would look something like that instead of something like that. How is that possible? Yeah, the negative sign here, and you will learn that in more detail when you go to Algebra 2. This tells you flip the graph, or so let's first say this is the -4, all of it is the y-intercept. The 1/3 is telling me this is a decay. And then the negative sign says that I will reflect about the x-axis. So again, let's try to do a table here and say some easy values, x, f of x, or y. If I know that if x is 0, y is -4, there is no math, because anything to the 0 is 1, you get the -4. If x is 1, then this is -4/3. Notice, I multiplied by 1/3. If x is 2, I multiply by another 1/3, so I get -4/9, and so on and so forth. So it starts at -4, and it decays. Here you would say, doesn't decay mean it would decrease? No, not necessarily. In this case, the decay, meaning it goes towards the x-axis, not goes to plus or minus infinity. So basically, what we are having here, if we try to draw that, and let's do it with a color so you can see the x and the y-axis. Here is the x. The y, I should have drawn it above. It doesn't matter. Here is the y. And since the numbers will not go below 4, yeah, I should have drawn x higher. Okay, so let's say each one of those is a third. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is -4. And this is -4/3, right? And so did we do that? So maybe here, somewhere here is -4/9. And this is 0. Maybe you can say this is 1, this is 2, and then we didn't go after that. So I start at -4. At 1, I go to -4/3. At 2, I go to -4/9. So basically, if that had been 4, not -4, 4 times 1/3, I would have started here and went down and became asymptote to the x-axis. The negative took this graph and flip it over. So instead of having 4, I got -4. Instead of having -4/3, I got positive 4/3, I get -4/3. Instead of positive 4/9, I get -4/9. So this is a mirror image of 4 times 1/3 to the x. Same thing, if I had made that -1/3, I would have started here, and then I would go down to -infinity eventually. But the x-axis is always going to be my asymptote, unless I add or subtract something. So if I give you another function and I say y equals 1/3 times 2 to the x, say +5, then y equals 5 is an asymptote. Here, without that, y equals 0, which is the x-axis, is the asymptote. If I say -3, then y equals -3 is the asymptote. Why is that? Here, the graph was increasing, right? So if you say, alrighty, so what if x is very small, meaning -infinity? It goes to -infinity. The 2 to the negative, or any number to the -infinity, is 0 times 1/3 is 0, and you get y equals 5. Here, because it's a decay, you would say, what would happen if x goes to positive infinity? 1/3 to the infinity, because this number is less than 1. When you keep multiplying it, you multiply it by itself, it's 1/9, which is 0.1111. You multiply it by 1/3 again, you get 1/27, then 1/81, then 1/243, 729, 2187, and so on and so forth. It gets smaller and smaller and smaller until it reaches 0, and you get y equals 0 minus 3, or y equals -3. That's why that becomes the asymptote. Whatever is added or subtracted. If you don't do anything, then the x-axis is the asymptote. It's as simple as that. Now, sometimes they give you the problems in a table, tabular form, and they tell you, find the equation. We may not draw it or graph it because we already know how to graph it. You just do a table, and oh, I think I have them in the back. Okay. Here are two examples. We just want to know how to find the equation. So how do we do that? You see here the x increases by 1, increases by 1, increases by 1. So if that was a really exponential function, then my y should be multiplied or divided by a constant, multiplied by the same constant, multiplied by the same constant, which in this case, basically, it's the b. So I should say b, not c. I wrote b, c for a constant. So what did I multiply the 45 by to get 30? Well, the b here is 30 divided by 45. If I simplify top and bottom by 15, I get 2/3. Oh, 30 times 2/3 is 20. 20 times 2/3 is 40/3. So yes, definitely 2/3. the y-intercept is 30. So here I can say y equals 30 times 2/3 to the x. It's as simple as that. Later, you will see that, in fact, is that the only way I can represent this function or any exponential function? No, there are infinite ways. What is this guy saying? What do you mean infinite? So how do I know which is the correct one? All of them are correct. What? I'm going to write it and then we'll discuss it. I can say y equals 20. 20? No, 30 is with the 0. Yeah, I know. But I'm going to use 20. 20 times 2/3 to the power of x minus 1. Or I can say y equals 45 times 2/3 to the x plus 1. Oh my God, this is so confusing. This guy, after we understood what he was saying, now he's talking, Arabic. Yeah, I know how to speak Arabic, right? No, ask yourself the easiest way. I can write x plus or minus any number in the word. It doesn't matter. But I would have to tell you, okay, if you write x minus 1, how do I return x minus 1 back to x? Wouldn't I add 1? Yes. So I go to x equals 1 and take this number instead. X plus 1, how do I make x equal? The exponent equals 1. I would subtract 1, meaning I have to go to -1. -1 is 45, so I can write it like that. I can write it as 40/3 times 2/3 to the x minus 2, because if I subtract 2, I go back to 0. So that's, I know you don't have to confuse yourself, but I know that sometimes they give you the equation like x plus 1. All what it says that instead of giving you the y-intercept, we give you what is the value at x equals -1, the f of x when x equals -1. Or the f of x when x equals 1 or 2 or any other number. Try to plot both on your calculator. You will get the same line on top of each other. Or if you draw it twice, you will get the same graph again. Okay, another problem you may face is that you come here to this function that you want to find its equation, or when you get this table and you want to find its equation, you see that, oh, the increment is no longer 1, it's 2. What? I know how to, if it's 1, I divide this by that and this by that, but if it's 2 or 3 or 5, how do I do that? And I can give you 2 and then 3 and then any other number. They don't have to be all increments by 2. I just, to show you, how it works. You say, okay, when you were giving me 1, I multiplied by a number. So if I give me 2, I multiply by this number twice. When you multiply by the same number twice, it's like you multiplied by the square of the number, right? So now we say, this is not b, that's b squared, and that's b squared. So now, instead of saying b equals 30 over 45, I would say b squared equals 64 over 4, which is 16, so b is 4. Not plus or minus 4, right? Because it's increasing. So you multiply by 4, but not by -4. And even if you multiply by -4 square, we don't show you the middle. So anyway, so now I can, even if I want, I can construct the 1 and the 3, because I know that I multiply by 4 to get 16, I multiply by 4 to get 256, and so on and so forth. So even though they are hidden, I still can find it. It's so easy. So now I can come back and say y equals, the y-intercept is 4 times 4 to the x. It turns out to be both 4, right? But this number can be anything. Can be 2, can be 3, can be -2. So that's the y-intercept. And likewise, I can say this y equals 16 times 4 to the x minus 1, or 64 times 4 to the x minus 2. And in fact, at -1, notice here I multiplied by 4. If I divide by 4, I will get 1. So I can say here y equals 1, which I don't, it's 1. I'm not going to write anything. 4 to the x plus 1. Try it. Set x equals 2. 2 plus 1 is 3. 4 cubed. 4, I'm sorry, this is -1, right? So if I set x equals 2, yes, 2 plus 1 is 3, and 4 to the third is 64. So when x is 2, I get 64. Here, let's say what happens when x is 2. When x is 2, this would be 2 minus 1. 4 to the 1 is 4 times 16 is also 64. Let's pick any other number. X is 3. 3 minus 1 is 2. 4 squared is 16. 16 times 16 is 256. Yes, at x equals 3, I get 256. And that's it. Really, now you can plot any graph. In class, don't use +1 or -2 or whatever. Play it safe, unless they tell you we want this form, y equals a b to the x plus 1. Now you understand. I will go to x equals -1 and see the value and write it here. Or if they tell you we want it in this form, a b x minus 1, I would go to x plus 1 and use that as my a. But otherwise, this is the a and this is the b, the multiplier. And if they give you 0 and 3, so for example, suppose we only give you 0 and 3, and then at 6, and so on and so forth, you would say, okay, I added 3, meaning I have to multiply by b 3 times, so b cubed equals 256 divided by 4, which is 64. So b cubed is 4 cubed, so b is 4 again. It doesn't matter. No matter what they give you in the table, you can always find the b easily. And I hope that covers everything you will need in Algebra 1 for plotting, exponential graphs. If you have any other questions or something that I skipped or didn't clarify, please let me know by dropping me a line or comment in the comment section, and I'll do my best to come back to you as soon as I can. Thank you very much for your time. Hope to see you soon. Have a great day. Bye.